Hello class, welcome to Unit 4, Video 7, the quadratic formula. So today you're going to learn how to solve quadratic equations by using the quadratic formula. So let's just look at an example. Competitors in the 10-meter platform diving competition jump upward and outward before diving into the pool. The height of a diver in meters above the pool after t seconds can be approximated by the following equation. H is equal to negative 4.9 t squared plus 3t plus 10. Okay. It says how many seconds it takes for the diver to hit the pool. The first thing I would notice is it's a quadratic because my leading term is a t squared. The next thing I would look at is I see that there's decimals. Okay, so what I would do is I would say, could I factor this? So if we're factoring, can we solve this one by factoring? Maybe, but with that 4.9, it just makes things really nasty, and I wouldn't even want to try. So factoring is out. That's a no. Okay, so no. Could we solve by graphing? Yes, we could. Okay, if we graph the function, we could find it. So yes, we could solve by graphing. Okay, so we could solve by graphing on this one, and I will show you how to do that in a minute. Our last resort then is if you maybe don't have a graphing calculator and you can't factor it, is to use the quadratic formula. So just to remember what the quadratic formula is, remember you have the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, my a is equal to negative 4.9, my b is equal to 3, it's what's in front of the t, and my c is equal to 10. So if I plug this one in, I would have negative b, so negative 3, plus or minus the square root of my b squared, so 3 squared, minus 4 times my a, negative 4.9, times my c, which is 10. Square root of all of that, all over 2 times a, which is a negative 4.9. I would recommend simplifying what is underneath the radical first. Okay, so I would take out your calculator and do that. So, sorry, mine's just loading here. So if you don't have your calculator, I would recommend grabbing it while mine's loading up. And if you do have it, start typing in what's underneath the radical sign. So that would be this 3 squared minus 4 times negative 4 times 10. All right, so looking at my calculator, I'm going to type in what is underneath my radical right here. So parentheses 3 and parentheses squared minus 4 times negative 4.9 times 10. And hit enter. Okay, so what's underneath there is a 205. Okay, so this simplifies. So I would have x is equal to negative 3 plus or minus the square root of 205 over 2 times negative 4.9, you can type it in, or it's negative 9.8. Okay, then to find my answers, notice how there's a plus or minus, I have 2. It's going to be x is equal to negative 3 plus the square root of 205 over negative 9.8, and x is equal to negative 3 minus square root of 205 over negative 9.8. Okay, so let's go ahead and do that. So on our calculator, make sure when you do negative, use the negative below the 3. So negative 3 plus second square root 205, and I would hit enter, and then take that answer, so divide by negative 9.8. So this gives me that x is equal to negative 1.55. So my answer for this one is negative 1.55. So what is x really representing? If I look up, x is, well, in this case it's actually t, but it's the same thing as x. So t is the time. Can I have negative 1.155 seconds? No. So that is not the answer we are looking for in this situation. So I try my next one. I have -3 minus the square root of 205. I would hit enter. Divide by -9.8. Enter, and I get 1.767. So for here, x is equal to where did the answer? 1.767 seconds. So would that one work? Yes. Okay, so that's how long it will take for the diver to hit the pool, 1.767 seconds. And just to remind you how to do this one on your graphing calculator, you would go, if you wanted to graph it, to your y equals, clear out any equations you have, and type it in. So you'd have -4.9x squared plus 3x plus 10. I'm going to make sure my window is to standard, so zoom 6. And I'm going to go ahead and hit graph. Okay, so there is my equation, or sorry, there's my parabola being graphed. And if I want to find this value, did I type it all in right? Oh, right here. Made a mistake. Forgot to put in the plus sign. So second, if you ever need to insert anything, INS is insert. Plus. All right, let's look at that again. Now it looks like a parabola. Here's where my negative answer. I'm not concerned about a negative time, so I'm not worried about that one. I need to find this one. So remember to find it, you go second, calc, which is above trace. That is a 0 value, which is number 2. To find my 0, I have to be to the left of it. So I'm going to just bring my little pointer over here. See how it's flashing? To the left of this point, yes. So enter, come down, enter, and enter. So it says 1.767, which is what we got for our answer. So if you wanted to graph it, you could as well. Or you can use the quadratic equation, quadratic formula. So moving on, quadratic formula. Okay, the solution of a quadratic equation in the form ax squared plus bx plus c equals 0, and it's where a doesn't equal 0, can be given by the following equation. So this right here is the quadratic formula. Do you need to know it? Yes. Okay, so I won't be giving you that on your test. In the quadratic formula is something we call the discriminant. The radical sign is called the discriminant. And what the discriminant it does is it tells you how many solutions you have. We've already went through how many solutions you can have. But if my discriminant is greater than 0, what that means is if it's positive, okay, I'm going to have two answers. The reason is I'm going to have negative b plus or minus some positive number, okay, over 2 times a. So that's going to give me two answers, okay, and here they are here. So this one will be 2 real solutions. Now it tells me if my square root is equal to 0. Okay, well, let's think about it. If I have negative b plus or minus, what's the square root of 0? Square root of 0 is going to be 0. If I add or subtract 0, it's going to give me the same answer. So this case, only going to give me one solution. One real solution. And the next one, if my discriminant is negative, less than 0, okay, I will have, it will not touch. This will be no real solutions. However, how many complex solutions would I have? I would have 2 complex. So there's no real, so graphically, it won't ever touch the x-axis, but there could be 2 complex solutions, thinking about that imaginary I. Okay, so that's when you'd probably have, you'd include that, I is equal to the square root of negative 1. So there's no real, that means it doesn't touch the x-axis, but there would be 2 complex solutions. Moving on to example 1. If you need to know the quadratic formula, you can watch, there's plenty of songs online that will help you. Most of them go to Row, Row, Row Your Boat. So, solving using the quadratic formula. Same as with solving any quadratic, you need to make sure you have x, everything onto one side. So this one would be x squared minus 12x subtract 28 is equal to 0. Okay, my a is what's in front of my x squared, which is 1. My b is what's in front of just x, so negative 12. And my c is the number by itself, so negative 28. After I have that information, okay, I'm going to go ahead and plug it into the quadratic formula. So x equals negative b, so this would be positive 12 plus or minus the square root. Negative 12 squared minus 4 times 1 times negative 28. Sorry, that got really crowded. All over 2 times my a, which is 1. So x is equal to, let's get out our calculator and type in what's underneath the radical. Especially when you have a negative, so make sure you use parentheses. So we're going to do parentheses, negative 12, end the parentheses, squared, minus, it's 4, times our a, which is 1, so I'm not going to write that one, times our c, which is negative 28. Okay, this is what belongs underneath my radical. It's 256. So x is equal to 12 plus or minus the square root of 256 over 2. Okay, 256. Sounds to me like it might be a perfect square. Let's try it. Second square root of 256. It is. So I would have 12 plus or minus 16 over 2. So let's type that in. I would have 12 plus 16, hit enter, divided by 2. So that means my first answer is 14. My other one is 12 minus 16, which we know is negative 4. And then we're going to divide that by 2, which gives me negative 2. So my two answers for this one is x is equal to negative 2 and positive 14. I had nice answers like this, no decimals, nothing of that. So that brings me to believe that maybe I could have just factored this. Let's just think about it. What multiplies to negative 28 but adds to negative 12? Well, 2 times 14 is 28, so if I have a negative 14 and a positive 2, they would add to negative 12, and if I solve, I would get x is equal to 14 and x is equal to negative 2. So that works. The directions did say solve using the quadratic formula, so that's what I had to do. But if you are given the option, notice how much quicker factoring can be. So really having your factoring skills up to par will help speed things up for you. All right, example 2. Okay, it still says to solve using quadratic, so we're going to do that. I look at it, everything is already onto one side. So my a for this one is 2. My b is 4, and my c is negative 5. So x is equal to, opposite of b, so negative 4, plus or minus square root b squared, so 4 squared, minus 4 times my a times my c, all over 2 times a. So 2 times 2. Okay, on my calculator, I can type in what is underneath my radical. I also know that 4 squared is 16, so I'm going to do 16 minus 4 times 2 times negative 5. And some of this you can do in your heads. You don't need to get out your calculator. So, whoops, what did I do wrong? Let's check it out. Go to, oh, I used the wrong negative. 4 times 2, I forgot, times negative 5. There we go. That's 56. I would try square root of 56. It's not a perfect square, but if you didn't know, you could try it. So I am left with, right now, x is equal to negative 4 plus or minus the square root of 56, and all over 2 times 2, which is 4. The next thing I would do is I need to simplify my radical. 56. What's my perfect square in 56? 4 times 14 is 56. So it's really square root of 4 times 14. So I have negative 4 plus or minus the square root. I'm going to actually write it out. So this would simplify to, this would be 2 square root of 14 all over 4. Okay, and you can leave your answer like this, but the one thing I would notice is, are both of these pieces divisible by something that this is? So these are all divisible by 2. So I'm going to go ahead and do that. So my final answer would be negative 2 plus or minus 2 divided by 2 is 1, so square root of 14, all over 2. And that would be my final answer. Okay, and that's how I would want it simplified. If it was a real life problem, I'd want you to type it in and get me the two answers. C, still using the quadratic formula. I notice everything is on the same side, so I would say A is equal to 3, B is equal to 5, C is equal to 4. Plugging it in, I have x is equal to the opposite of b, so negative 5 plus or minus square root of 5 squared minus 4 times my a, which is 3, times my c, which is 4, all over 2 times my a, which is 3. I'm going to save some time. You can type it in if you want, but underneath my radical, if you type that in, you get the square root of negative 23, all over 6. Simplify my radical. Square root of negative 23. I know it's negative, so I'm going to write it as negative 1 times 23. 23 is a prime, so I can't break it down any further. So my final answer will be x is equal to negative 5 plus or minus I square root of 23 over 6. And there's no more simplifying that can be done for that one. Okay. So that is examples 1, 2, and 3 using the quadratic formula. If you have any questions on that, please let me know. If you'd like a break before we get to the word problems, now would be a good time to pause the video. Otherwise, we're going to move on and finish up with these last 2 word problems. So example 4. A path of a football thrown across a field is given by the following equations, where x represents the distance in feet the ball has traveled horizontally. So that's important to know. So x is the distance in feet traveled horizontally. And y represents the height. Okay, so there's a football being thrown across the field. So there's the ball. So my x is the distance this way, and my y is my height. Okay, so how high it is. In feet above the ground. About how far has the ball traveled horizontally when it returns to the ground? Okay, which one would be talking about returning to the ground? That's going to be your up and down, so that is your y. Okay, and what's true about your y if you're on the ground? Well, if I'm on the ground, my height is 0, so I'm going to let y equal 0. And what I want to know is how far has the ball traveled horizontally? Well, I'm going to solve it for x. I see that this one is probably going to be best to solve by quadratic formula, or you could graph it. So I'm going to solve it with the quadratic formula. So my a is negative 0.005, my b is 1, and my c is 5. If I plug it in, I have x is equal to negative 1 plus or minus the square root of b squared, 1 squared, minus 4 times my a times my c, all over 2 times a, so 2 times negative 0.005. So x equals negative 1 plus or minus. If you type all that into your calculator, underneath the radical, it's going to simplify to 1.1, all over negative 0.01. Okay. From here, you would get 2 answers. If you do x is equal to negative 1 plus the square root of 1.1 over negative 0.01, you get negative 4.881. Okay. We're talking about the distance traveled horizontally. Okay, so we're going this way. We do not want a negative distance, so that one is out. Then I go ahead and I try x is equal to negative 1 minus square root of 1.1 divided by negative 0.01. If you do that on your calculator, you get 204.881. So this one would be my answer. The distance horizontally is measured in feet, so I would label it feet. So basically what they're saying is when the ball hits the ground, over here, this distance was 204.881 feet. Okay, that is example 4. If you have questions, please let me know. Example 5, an object is shot straight upward into the air with an initial speed of 800 feet per second. That's talking about the velocity, that 800, and notice it's in your equation right here. Okay, the height h that the object will be after t seconds is given by this equation. When will the object reach a height of 1,000 feet? So what they're saying this time is I have something being shot up, and it's going up and up and up and up and up. Okay. Down here, this distance is my time. They want to know when my height is 10,000 feet. So if they want to know when my height is 10,000 feet, I'm going to plug in 10,000 for h. So I really have 10,000 is equal to negative 16t squared plus 800t. This is one where it's quadratic. I'm going to get everything to one side, so 0 is equal to negative 16t squared plus 800t minus 10,000. Okay, you could try and take out a GCF and factor, or you can use a quadratic. It's up to you. I'm going to go ahead and use the quadratic. So it's when my A is negative 16, my B is 800, and my C is negative 10,000. So quadratic, opposite of B, so negative 800, plus or minus the square root of B squared, so 800 squared, minus my 4 times my A times my C. All over 2 times 8, 2 times negative 16. On my calculator, if I type it in, I'll have x is equal to negative 800, plus or minus, all of this will simplify to the square root of 0, all over negative 32. So there's only going to be one solution, so negative 800 divided by negative 32 will give me 25. And what is x representing, or in this case it's t? It is time, and the time is in seconds. So at 25 seconds, the object shot up, so at 25 here, will be at 10,000 feet. All right, that is the end of Unit 4, Video 7. So if you have any questions, please ask. Otherwise, this is the last video in Unit 4. So have a nice day, and I will talk to you later.